Yeah.
Okay,
And
great.
we are all ready to go.
Great, super.
All righty, let me go ahead and kick it off. Thanks everyone who's joined us for today, and for those of you who are joining in at a later date, we're glad you could be there as well. You'll get a chance to hear my dog Milo in the background probably some of the time as well. Dr. Marks is a big fan of his wonderful dog as well, so that's sort of all the family there. Anyway, my name's Dean Klein. I'm the Global VP of Media Relations for pi-top, and know many of you already from our workshop in January, and I wanted to just kick off the webinar to set the stage for you, and then we'll go ahead and let Will and Rez take it off from there. We have put together this wonderful set of technology that they're going to introduce you to. We have designed and manufactured it in our own facilities to get it ready for the solar car. It's exclusive to the solar car program, and we're so pleased to be able to give you this kind of access to this kind of capability. So with that, I'll kick it off, and they'll describe a little bit about the technology and the timing and how you can be using it with your cars. I'll throw it over to Will and Rez.
Great, thank you, Dean. Are we good? We're not muted?
We're not muted.
All right, so let's switch over to our presentation so you can take a look at what we're looking at. Okay, take it away.
Hi, everybody. I'm Rez, and this is Will. You might recognize Will. You probably already met him from when he was in the US, dealing with the beginning stages of the Solar Car Challenge. So like Dean said, we're just going to run through the pi-topHELIOS boards, what we think you could do with them, how to use them, what you can make, and then right at the end, we're going to throw in some technicals. So just going to introduce myself. I'm Rez, that's me, third from the right. I work in the pi-top China team. This is our team.
I do also work in the pi-top China team, but sadly, I was away when this photo was taken, and this is the only good photo we have of all of us together. So.
Yeah, the team's grown quite rapidly in the last few months as well.
You can just imagine me just off the camera there, if you like.
You might notice we do have an office doggo. His name is Rhodey, after Colonel James Rhodes from Iron Man. And we love Rhodey. Rhodey is an integral part of the team. This is us trying to dry him off with a pi-top t-shirt after he's absolutely drenched from the rain. But he's great. He's a great engineer as well. He designed most of pi-topHELIOS as well.
You see, we got a bit of a thing for dogs in pi-top, but with Dean bringing his dog along, and we wish he was here as well, Rhodey, to join in the fun.
So, like I said, we're going to run through pi-topHELIOS a bit. pi-topHELIOS is just a great platform for the Solar Car Challenge. We wanted to make it as useful as possible and keep with the company ethos of low floor, high ceilings, wide walls. So what this means is we just give the basics, we give a wide range of usability, and just make it as useful as possible, and you customize it however you want. We give you the foundations of the house, and you construct it. You decide how you want it to look, what you want to do with it, and just anything and everything.
Like a Swiss Army knife. They have this in America.
Swiss
right?
Army knives, yeah.
Yeah.
So, like I said, it keeps in touch with the company ethos. Here's a pi-top from an episode of MacGyver, where they actually used the pi-top 1 to stop a nuclear missile from hitting California.
We don't recommend you try this, but if you did, it would work. You can do that with a pi-top.
Apparently. So like I said, it's just a Swiss Army knife. You have a basic communication system. You can collect all the important telemetric data you want, and then you relay that information from the solar car to your chase car. Any information you want to send, you can send. And then lastly, it's open source. We're going to release all the schematics to you, show you exactly how it works, and also
the software as well.
And the software. So you can customize it however which way.
Mm-hmm. So we're just going to talk about the hardware that we'll be sending you. We've already sent this out, so some of you might already have this in front of you and have had a go with it. But if not, this is what you'll be getting soon. So the kit basically, in its essence, consists of two parts. There's the solar car board there on the left and the chase car board on the right. Now, as the name implies, the solar car board goes inside the solar car. and it collects a lot of data from the solar car. It then sends it wirelessly back to the chase car, which, again, as the name implies, that unit is sitting inside a pi-top that is inside the chase car for team members inside the chase car to view the data from the solar car. So the kind of stuff that you've got on board the solar car board there, things that you can use to collect data. You've got a long-range radio, obviously to make communication between the solar car and the chase car. You've got a GPS module, so you can pick up your position and speed in real time, also used for logging position of the cars. You've got an 8-channel analog to digital converter, an ADC, so that can measure analog voltages up to 65 volts. So that might be your battery array or your solar panel, for example. You've got a 1.3-inch monochrome display. That's totally customizable. You can do what you want with that. The basic firmware that comes with it has some features on the screen there, which you'll see, and I'll show you in a minute, a little demo we've got here. And you've also got a bunch of other sort of fun little things, buzzers, buttons, a full color LED, this kind of thing, just to sort of mess around and make it more fun. We also pack in some extra accessories. So amongst them are a GoPro mount designed to go with the solar car board. That's the thing you see in the bottom left there. It basically allows you to, if you want to install your solar car board using GoPro accessories like a bar mount or something, you know, or I was going to say a chest mount, but I can't see why anyone would use a chest mount. But you can see a lot of good off-the-shelf GoPro accessories to mount things on there. We've also got an external antenna for the long-range radio, so that will give you very good range on your long-range radio. In the right circumstances, you can actually get up to about 10 kilometers on that, but don't quote me on that because we haven't tested it to that range. It's not designed to go that far, but the antenna will help with that. And we also ship an external GPS antenna because we know a lot of these solar cars, you've got a lot of big chunks of metal everywhere. We don't know where you're going to put the solar car board. And if it's obstructed its view from the sky, then you won't get very good GPS signal. So the external antenna will help you optimize that signal. So the next slide is basically just a quick run through of just when you're looking at the board so you can see where these things are. So just going around in no particular order clockwise. You've got the screen in the top left there. The GPS module is on the top right and the connections for the antennas. The radio module's up there as well. On the middle, on the right-hand side, you see the programming USB. So that's where you program in your own software onto the board using the Arduino environment. We'll talk more about that later. And then on the bottom right there, we've got these screw terminal inputs, which are basically for connecting up to, like I said earlier, your batteries or your solar panels. Those are sort of black screw terminals. The ones down in the middle there, the MCU IOs, those are gray. Those are for connecting to the MCU. If any of you have used Arduino before, that's a bit like using an Arduino. So it's a totally customizable in-out pin that you can use to sort of turn things on, turn things off, control your own hardware that you connect up to the solar car board. There's a relay on there. So a relay, just a switch that's controlled digitally. So if you want, you can write something in your software that maybe you've hooked up your headlamps to this relay and you turn them on and off wirelessly or something like that. And then finally, in the bottom left, you've got the power input and the on-off switch. Quickly turning over to the other side of the board, on the bottom there, you've got the hole where you mount in the GoPro mount. So that's one of many ways you can mount this thing. And in the top left, we've got a coin cell or a button cell holder, which takes a small battery, a CR1220 battery, which is basically used to allow the GPS to keep time even when the board is turned off, which can be useful if one of the metrics you're collecting is time and you're interested in it, then that helps keep things accurate all the time. And then finally, the much simpler board, the chase car board, the other board, that one is largely the same, but with a lot of the features removed because they don't really need to be there. So all you've got there is you've got the screen and the buttons and the buzzer, and then the radio module as well. And that's programmed in the same way, using that USB port on the right-hand side. But otherwise, it's largely the same board, just without the GPS, without the ADC, without the relay. That just works as a sort of receiver to communicate with the pi-top. And sort of to show you that, we've actually got a demo here. I think that's up next. Is that right?
No.
No, it's not. Over to you guys.
So, like Will said, pi-topHELIOS boards, pretty versatile. So we have photos of how they might be used. So you have your GoPro mount. You can mount it on another set of GoPro accessories and put it anywhere else in the car. And then we have a photo in the center here of it wired up, just powered by maybe your lead acid batteries using a relay. using one of the IOs and using one of the ADCs. So that's the solar car board. And then the chase car board, like we show here, you connect into a pi-top using the add-on rails, and then it just slots in like any of our other add-ons. And all the data comes in nicely through here. So this is the pi-top telemetry system, which Jarrett has very kindly developed. This is to help anybody and everybody get the boards working straight out of the box. So like it shows here, you can collect speed. You don't need to connect anything up for that. You can measure current through the ADCs. You can measure your mains battery voltage and your auxiliary battery voltage. You can also log the data, and we do have a demo here.
Yeah, we do. So if you want to switch over to the camera so you can see us full screen, there we go, that's good. So what we've got is, this is the pi-top with the solar car system installed. So that's basically, that is the solar car board sitting inside the pi-top there. So you can see it. Oh, let's try and get it up close. That's good. No, that's all right. I'll move that back. So that's the solar car board there, receiving data right now from the chase car board. Sorry, that's the chase car board, receiving data from the solar car board, which I'll show you in a minute. And then on the screen here is the pi-top telemetry system, which is a piece of software. Again, all of this will make available, very easy for you to install. This then, as Reza said, this is what shows you, this is what we ship with, that shows you basic information about speed and current and voltage. Obviously, it's not showing anything right now because the solar car board isn't connected to anything, but they are currently hooked up together. So this is the solar car board in action. So it's got its little antenna on it. Yeah, I'm afraid you can't see on the screen here. It's a bit sort of blurry up close, but that's basically a little screen. You've got the buttons, so you can choose through the menu here, and on this menu you can select different options for different things you want this board to do. Again, you can have a play with it when you've got one in your hands, and our documentation explains sort of more about how to use it, so I won't sort of drag on here by going into it. There we go. So we go back to the main menu, and it sort of gets its GPS fix, and it starts picking up data, and it sends it from the solar car board over to the chase car board. The chase car board picks up all the data, receives it all on there, and then displays it on the screen. And all of this stuff will be available on our GitHub, and we'll be talking about that in a minute. And all of it is totally customizable. So this is really just the very basics we've given to get you off the ground. But the sky is the limit with what you can do with all of this hardware. I really can't emphasize that enough. There is so much you can add in. We had a lot of fun just throwing this together, but we didn't want to get too carried away, to leave you guys some space to sort of do your own thing as well. So let's go back to the presentation. Okay.
So here are a list of things that we think you could make. We have the generic things, like Jarrett showed, like Will showed on Jarrett's software. You can measure the battery voltage, you can measure the energy you're generating, you can even collect light data, you can do all those things. And then you can do the more basic things that you might find on a regular car, like windshield wipers or horns or headlamps. And then you can do the crazier things, like you could control your spoiler angles if you wanted to have a spoiler, or you could control the suspension firmness. We just wanted to give a wide range of things we think you might want to do, but don't think of this as an exhaustive list of everything you might want to do. I'm sure you'll create weird and wonderful things with this as well.
This list makes me want to enter pi-top into the Solar Car Challenge. I know we're not a school, but I want to build our own pi-top.
Yeah.
And actually race in the race and just cover it in technology. Dean, I think we're going to have a chat about that later, about if we can enter a team pi-top into the Solar Car Challenge, because this has been way too much fun to play with, and I want to get involved.
Yeah.
Will, I think a pi-top solar car demonstration vehicle that we have in our own category is entirely appropriate. Terrific.
All right,
love that idea.
Good. What's next? All right, so we'll just quickly touch on these schematics here. So we're going to make all the schematics available in sort of full resolution, not these tiny pages here. It is totally up to you whether you use them or not. But like I said, we're making them available in case you're interested in that sort of thing, or you want to know how we've done it. And we'll talk about this in a moment. But we're also going to have a forum available for you to ask any questions about it. and Rez and I will be happy to answer any questions. So the rough format of the schematics here is in the top left there, you see what we call the root page. That's a page that brings together all the different schematic blocks. It links them all together. And those blocks are in no particular order. In the top center there, you've got the ADC, so that's the analog to digital converter, collecting all those analog voltages. So those are the parts for that part of the circuit. In the top right, you've got the 1.3-inch monochrome display. Bottom right, you have all the power regulators that are generating power on the board. In the bottom middle, you've got the GPS module. And the bottom left, you have the microcontroller that brings it all together and controls the whole system. If any of you have used the Arduino environment before, it is in its essence at the core, it uses the same microcontroller as the Arduino Zero. So it's a very familiar architecture for anyone that's played with Arduino, and that sort of brings the whole thing together. Like I said, take it or leave it with the schematics, but more information will be available in the documentation we provide. And also, any questions, please do just wing them over on the forum, because this is what we do all day, every day, and we love to talk about it. So we'd love to, the whole point of this program is to help you guys learn and get into electronics and software. So, by all means, this is the gateway drug to get into it, is definitely the schematics and the software. What's up next?
Debugging. So like Will mentioned, we have the pi-topHELIOS Getting Started Guide. All the links will be available at the end of this presentation, so don't worry. The Helios Getting Started Guide is just a great way for you to use the board straight out of the box. It has all the basic information, and it also leads you to how you might manipulate the boards even more. It's going to be your first point of reference when things go wrong. Also, like Will mentioned, we have a forum available. It's the pi-topHELIOS forum. The link is right there. If you have a problem with the boards, Will and I will, if you just post a question there, then Will and I will be more than happy to help you out with it. It might also be someone else from our team. It might also be someone else from the Solar Car Challenge group. And then you also have the Arduino website. Like we said, the MCU is the same as you might find in Arduino Zero. So there are already libraries written for it to manipulate the IOs, to manipulate the ADCs. So you can really just tinker with everything that's already available. Then if you have more problems, you have Google to refer to. You have YouTube to learn new things. Honestly, YouTube is just so helpful for learning new software and new hardware. We use it every day. And then data sheets and schematics if you want to really get down and dirty with the technicals. Safeties and checks. Now, we understand that you're dealing with a lot of high voltage things, so you need to just be careful that they're not shorting with one another, and just keep them isolated. You need to always think, can this overheat or can it set on fire? It's weird that I have to say that, but it's also necessary sometimes. Especially when you're debugging, you do need to be careful of tiny cables. Label things and make it very, very easy for yourself to keep track of where things go, because it's so helpful when things go wrong. Be innovative, do crazy things, but be very, very realistic with the time you have remaining. A few tips as well. When it comes to hardware, if you can't get something working, always just check, is it connected to ground? Like, it's weird how many times it is. And with software, you just need to get a cycle going where you change a little bit of code, you upload it, check it works exactly how you wanted it to, and then move on. And if it doesn't, you just go back a step and change it back. It's so useful to get that iterative cycle going and going and going. So then lastly, we have some useful links. So we have all the data sheets here in these slides. And then we have links to the schematic, the forum, the Getting Started guide, and then GitHub as well. There's a link to Wikipedia for potential dividers. And you can also download the Arduino IDE if you want to manipulate the MCU firmware. So we went through that pretty quickly and chucked a lot of information.
Blasted straight through it. But now we've got a little sort of Q&A session at the end. If there's anything we missed there, if there's anything that you've got any specific questions about, then please do just wing them our way. Zoom is capable of sort of, everyone can jump in. So, I don't know how we can do this. We can do sort of raising hands or just jump in and speak. Maybe Dean has some questions as well. As a viewer, he might have noticed that we missed something. And also, just a disclaimer, I've just noticed that our camera is running low on battery. So if we suddenly disappear, we'll be right back on a different camera. Because even though we're one of the best technology companies in the world, we have a camera that runs on batteries, and I'm not really sure why. So that's that. So Q&A. Go.
So I'll set up with a statement that kind of tees it up for you all. We recognize that not every team will be able to take full advantage of all the different capabilities. If you feel like you just want to take advantage of a few, pick the ones that are most interesting for you. Again, low floors, wide walls, high ceilings. We want you to be able to go as high as you can. We want you to go as wide and variety as you can, but we also want easy entry. So if it's daunting, if you're a new team with a brand new car and you're trying to work things out, pick a couple of your favorite ideas that you saw in the presentation from Rez and Will, and maybe try those first. And once you accomplish those, then maybe add and add. There's a phrase we use, trying not to boil the ocean. And that phrase is about not trying to do too much all at once. And so pick a couple of your favorite ideas that you've heard here to implement that way. And then I think that'll be great. For Rez and Will, here's a question for you. So let's talk a little bit about the logistics of having the pi-top laptop in the Chase vehicle. Obviously, they're going to be driving all day long. What would you recommend as far as remote power for the laptop while it's driving during the day? It's very possible that they'll be going 10, 12, 14 hours high power usage. How would you suggest that they power up and keep the laptop going while they're chasing the vehicle?
So that's a very good question. And the answer is, and you caught me on the back foot here, that originally we wanted to have a plug to plug into the car. But unfortunately, we didn't have time to create that in the end. So what we recommend instead is that the pi-top will push over 8 hours of battery on a full charge. So you'll definitely have enough charge to go through most of the day. But then the solution will have to be that it is charged up overnight, or if you have an in-car power inverter, you can sort of plug into the mains there. Like I said, in future, I think we'll be doing it with a plug to go into the car so we can keep it running, because actually the hardware is capable of running off a 12-volt sort of socket. But for now, it'll have to be 8 hours during the day and then charging overnight.
And just using the 12-volt converter in the car if they want to have an additional power source in the car during the race. Is that right? Yeah. If they've got an adapter for it, then they can do that too. Perfect. I'll see whether there are any other questions, and I'll throw another one in. Okie dokie.
Is there anybody else with any questions?
I have a question.
Yeah.
Can you hear me?
Yeah, we got you.
Did not see an antenna connection for the pi-top unit. How does the antenna come into that?
So we went through a few different iterations of how we wanted to do this, but what we did in the end is the pi-top unit. Oh, we're all blurry.
Oh,
I don't know why we're all blurry.
there we go.
There we go. So the pi-top unit actually uses, and I'll unplug this so you can see it. The pi-top unit uses a half wavelength wire antenna. So originally we were looking at using an external antenna. We talked about drilling a hole in the side of the pi-top and having this SMA connection on it so you could connect a little antenna. But in the end, it turned out that actually just using a piece of wire that was exactly, it's something like 12.6 centimeters long. But that actually means that it's tuned to the 915 megahertz that the low-RAR radio uses, which means it's perfectly good for this application, which is great, because we didn't want people drilling holes in pi-tops and making everyone's life more difficult. So that actually comes with the board. So with that one, you don't have to do anything. The board goes in, the wire sits in the back there. I realize now in retrospect that using a green wire and a green pi-top means it's very difficult to see. So that wasn't a great idea. Maybe we'll pick red next time. But that doesn't detach. And then on the as you saw on the other board, you've got this SMA connector on the top for an external antenna. If you are the type who likes to sort of get creative and mess around with the hardware, the footprint for the antenna, which is on here, and hopefully my camera will focus on that. Go on, camera. Can you do it? I'm waiting for the camera, but it looks like it's not gonna. Nope, the camera's not going to focus on that. But there is a footprint here that will allow you, if you're interested, you can actually solder on your own SMA connector, and you can put your own antenna in there. So as I said, on one of my sort of pi-tops at home that I mess around with, I did connect a little antenna on there, and then I had a coaxial cable going to the back of the pi-top, and I had an antenna screwed on the side. But in the end, that was just more complicated than it needed to be. This system actually turned out to work fine. Does that answer your question?
Yes, it does. Thank you very much.
You're welcome.
So anybody else?
Don't be shy.
Okay. Well, like we said, we're going to make this video available to everybody. And if you have any other questions, then feel free to message us on the forums.
I'll also add one more thing. We should also describe, Rez, that you're going to be at for the weekend of the scrutineering and available to help troubleshoot and install and so forth. Why don't you describe a little bit about what we might accomplish on the weekend?
Right. Thanks for reminding me. During that weekend, I will be available to help you with last-minute debugging, as well as make sure that you've done all your own safety checks and all the good and happy things that come from that as well. But yeah, I don't expect to have many issues because I'm sure you all do a great job anyway. But I will be there.
Got to say, I'm really jealous. You guys are going to have a great time. Originally, I was going to be going out, but unfortunately, I'm not able to. So Rez is going out in my place, but it is going to be a great weekend.
I am looking forward to it so much. I wish we had this type of stuff in the UK as well.
Well, the problem is that you need sun for the solar car.
Yeah.
And we don't really have much sun.
And you need big roads, which we don't have in UK.
Yeah, so it wouldn't really work, unfortunately.
So from a timing standpoint, everybody, Rez will arrive Friday night over the weekend of scrutineering. He'll be there through the weekend. Our CEO, Jesse Lozano, will be there for Sunday night, and then Monday, then the Monday night banquet, and then Tuesday. So we'll have a good presence. I'll be there as well. We'll have a good full presence there to help out in any way you need, answer any questions you have, and make sure that you're successful with the technology and have a great race. So that's that gives that background.
I have one more question, if possible.
Yeah, absolutely, yeah.
Okay, we have a very tight amp usage for our auxiliaries. So what is the amperage pull on the unit that's in the solar car?
That is
a very good question.
Excellent question. So I have not sat down and measured it, which means that I'm going to right now look at the board and think about what everything is pulling. And if I had to guess, we have the low-R radio, which peaks at about 100 milliamp. The GPS antenna doesn't use too much. The Cortex M0 sort of does. So,
what about the OLED screen as well?
And the OLED screen. So I'd put it in the order of, let's call it a couple hundred milliamp. Maybe let's call it 200 milliamp at sort of 5 volts odd. So if you're pulling it off 18 volts, it's going to be significantly less than that. We sort of designed it with a bit of power consumption in mind, but what we thought was that, because we presume that you are using a big old lead acid battery to power this thing, that, your amps, I see you laughing there, so I might have got that wrong. If you're running your auxiliaries off small lithium, then I've miscalculated that. But we think that compared to the other things that you're running, hopefully a couple of hundred milliamps at 5 volts will be all right for you. So that'll come down to obviously more like sort of 50 or less milliamps if you're powering it off 18 volt. Yeah, is that sort of frugal enough for you on the amps?
You never know. And we're running AGMs that are 18 amp hour, so we have them switchable, but we've noticed that we are pulling right now over 2.5 amps for the whole system, so it's a little bit scary.
Wow. Okay. Well, hopefully this won't contribute to that, but it's an excellent question. So actually, I think when I get home, I'm going to plug this into my amateur and actually find out, because I checked in the early stages, but we revised the hardware since then, and I would be interested to know. So I think I'll find the answer and I'll pop it up on the forums, and you can use it to sort of joule count and check you've got the juice.
Excellent. Very good. So when do we actually expect the Helios system to be arriving? Because I don't believe we have received it yet.
They were shipped out this week, and they in priority, and so they should have arrived yesterday or today. But if not, then check the mailbox tomorrow, if you will. But we sent them all to each school, and so to the main address that Dr. Marks gave us for each school. So if you haven't received them by, let's say, tomorrow, please drop an email, drop a note on our Slack channel through William, or whatever you need to do to make sure we can track them. We have tracking numbers for everyone we shipped out.
Excellent. Very good. Well, unfortunately, I'm not in Illinois, so the kids will have to look. I'm on vacation right now. They're taking care of all the other problems.
Have them take a look for it then. Yeah.
Nice. Right.
All right, then. I'm going to wrap things up. It was very nice to talk to all of you, and I really hope you got something out of it. If you didn't, then we have the forums available. And like Will said, you can always use William as a point of contact for us as well.
Yeah. Dean, do you have anything else that you want to add to that?
No, I just want to say I want to thank the two of you for your amazing hard work on this, and we are really excited to see how each team uses the technology. We know that this is a great step forward for you. We've heard a lot of feedback from that. Our job and our wish is to make sure that you have the technology to make this as the best race you've ever had. And we're very, very excited to be technology partners with you on this, and look forward to a terrific race.
Yeah, well said. We are very, very excited. I cannot wait to see what you guys do with this. We've had, like I said, we've had a lot of fun just playing with it ourselves. And also, the whole program is fantastic. So Rez will get to be there and watch the whole thing, and I'll be watching from China. Yeah. Thank you very much, everybody. It's been great.
Cheers. Bye-bye.